in the last class, what we saw, we introduced a calculus, right? And what we saw is a differential calculus. Okay. So if you remember what's the differential calculus we saw? So the differential calculus is something like that. If you have some curve, it can be any curve. Okay. So then what was the different? Okay. So if I call this as a function f of x, okay, and then the derivative is what? Derivative is the slope of the function, slope of the tangent to the function. Okay, so for example, if I take at this point, derivative at this point, that is some x star. Okay, so derivative of this point is what? This is nothing but the slope of the function at this point. So this is equal to df by, if I call this as x, df by dx at x is equal to x star. Okay, so that's what we discussed, we saw last time. Okay, and then we also wrote down the properties of the derivative, some function, right? So some of the properties we will be using it now. So now today we will try to find some derivatives of some functions, standard functions. Okay, like your sine of x, all those things. Many of the things you have to mug up. Okay, you will prove it in your 12th standard. For now, for time being, you accept that. Okay, so that you will prove it later on. So now, first question I am asking is, okay, let me tell. Okay, so what happened? If you remember, there was a function f of x, and we are going to take the derivative of the function, right? Derivative of the function is what? Tell me. df by dx. Oh, sorry, df by dx. Is that right? That's a derivative. You can understand it, right? You remember it or not? Remember. So, suppose if the f of x is equal to a constant. What is that? It is just a constant. Can you tell me what will be df by dx will be? This will be 0. Why this will be 0? Yes, so if I try to draw, okay, let us see what happens. What do you mean by, how to understand this? You can prove it, but I prove it in a very different way. Okay, from the limits also you can prove simply. Okay, so limits of proof is simple now, because see what happened, what is that? See, if you remember, what is df by dx will be limit of x tends to 0, f of x plus h minus f of x delta x. Correct? F of delta x minus divided by delta x. Correct? So now when this is a constant, okay, this doesn't have function of x at all. That means a minus a. That becomes 0. Okay, so this is 0. So irrespective of whatever the delta x, you got a minus a, that becomes 0. So that's what this will be 0. But it's an easier way to prove it also. Okay, and it graphically also you can understand it very simply. See, for example, let me take it. Let me take the curve. Instead of drawing this curve, let me draw another curve. Let me draw this curve. So if it is something, the curve is something like this. Okay. Okay. So let us try to assume, suppose this is the curve. And what are you going to do? Let us try, this is our f of x. And I am going to find a slope derivative at certain point. That's what? X star. Okay, so what is the derivative of that point? That is nothing but draw the tangent along that one, and that slope of the tangent is the derivative at x equal to x star. Is that correct? Now you think of, if I, let us assume the case, if I move the x star from here to here towards the left hand side, what will happen to the slope?
It will start getting parallel to the x.
Yeah, no, see, towards the end will come. Suppose I am not drawing the curve properly. Suppose if, oops, sorry. So let us draw the curve something like this. Okay, and let me draw the tangent again. So I'm not able to draw properly. Let us draw the tangent. Where you want to find that? Let us draw the tangent here. Okay, at this value, at this point. Okay, so this is the tangent, and let me call this as x star. So this is df by dx at x is equal to x star, or simply at x star also. So now, if I move this point towards left hand side, so it's a tangent, na? So the tangent keep rotating. Am I right? Slowly, because every point since the curve is come, the tangent keeps changing. So now, as it reaches here, the tangents become like this, right? Now when it goes here down, it becomes like this. So when I take out the minimum point, say for example, let us take, this is the value where it is falling minimum. I'll call it as xm. So at this point, what will be the tangent? Just, yes, parallel to x-axis. Am I right? So this will be your df by dx at x is equal to xm. What is the slope of this line?
0.
Correct? Slope of this line is 0. Okay. Now, let me remove all these curves. Let me remove all these curves. And let this be the line. Let this be my f of x. Correct? F of x what? If this is a, f of x equal to constant. Correct? Am I right? Now what will be the slope of this line? 0. And that's what happening here. Clear? So that's what derivative of a constant will be equal to 0. Okay, so this you should remember. And then let us try to do one more. There are many properties we have. So one more thing. So, okay, I can ask you a question. One question we can ask is there any function? One very important function which is called as a Euler. It's an exponential. That number comes out to be Euler number. That I will show you what is that. Do you have a function for which df by dx should be equal to f? What it means, the derivative at the x, any value, should be the function value itself. What the point I am telling you is there any function? So, is there any function, say something like this or whatever it is. So, and I take the slope. So, the slope value, that is df maybe at this point, x star. Df by dx at x is equal to x star is equal to, this is f of x, f of x star itself. That is equal to this value.
Both should be the same line.
What? It can't be. Yes. So let us try to find. Is there any? If I ask you a question, can you have a function? Okay, and that gives you a very interesting function. So what happens is, suppose let us take the function is okay. How to do it? So let us write. Let us take the function of some function f of x be equal to a power x. Okay, so a is some constant to the power of x. Okay, and now you remember we can write it in log form. You remember? We are not going to find that max once I told you. Suppose if you have y equal to a to the power of x or a to the power of x, what you do? Log base a of y gives you x. It means, what it means, a to the power of x will give you y. Or you will, what the log is, out of the log is a question, what should be the power of a? That should give you the answer y. Okay, then you say that is x. Okay. Or you can write like, we didn't write it as x there. In the max, we write it as b, I think so. Correct? A power b. So the question is what should be the power of, so log, when I ask you log of a y. So it tells you what should be the power of b. Okay. So that you will get answer to be y. So if you get log of base 10 of 1. So then what it says, what should be the power of 10? So 10 to the power of what is that element, that what is that number, you should get answer to be equal to 1. You can easily tell. What should be?
It's 0.
0. So this will be 0. This is a log. Okay. So we will see about it later on when you do in a max class. So this can be written in the logarithm form also. Okay. So let us try to see. Okay. So now let me take the derivative of it. What's the derivative of it? df by dx will be equal to, tell me, limit of delta x tends to 0, f of x plus delta x minus f of x delta x. Okay? Okay, tell me. So this will be what? So our f of x equal to a power x, correct? So then this will be what? Limit delta x tends to 0. Okay. So what this will be, tell me? A power x plus delta x, correct? You have to just replace f of x, na? F of x, it will be x. F of x plus delta means the x will be replaced by x plus delta x, correct? Minus a power x, that's f of x, divided by delta of x. Can you follow what am I doing? If you have a doubt, you ask me. So that's equal to what? Tell me. Limit delta x tends to 0. So this is what? A power x into a power delta x. Am I right? So this will be what? A power x into a power delta x. That's the formula, na? A power m into a power n equal to a power m plus n. Correct? So that's what we have done here. So a power x minus a power x divided by delta x. Correct? So this will be what? Tell me. Limit delta x tends to 0. So here a power x I can take commonly outside. So when you take a power x commonly outside, what we are having? A power delta x minus 1 divided by delta x. So now if you see, this is a power x. This doesn't contain delta x at all. Even if delta x goes to 0 or doesn't go to 0, this is not going to affect this at all. Okay, so this I can write, instead of writing it, I can write it in front of it. I can take this out of this. So this will be what? Tell me. A power x limit delta x tends to 0. A power delta x minus 1 by delta x. Now this is interesting. Why this is interesting? What is a power x?
Okay, f of x.
So, and this is what? This is df by dx, right? So what you are getting? Df by dx equal to f of x, and limit delta x becomes 0, a power delta x minus 1 divided by delta x. Correct? Now can you tell me what this is? From this function? Okay.
F of delta x minus 1.
I will tell you. What is our f of x? A power x. Correct? Now, if your x is equal to 0, so what happens? So we are having df by dx equal to limit delta x tends to 0, f of x plus h minus f of x divided by delta x, right? Suppose if your x is 0, okay, so what happens? So if f is 0, so if you remember last time I said df by dx, you can write as f prime also. Okay, so let me write it as f prime, that makes it short. Okay, f prime for x is equal to 0. Then what happens? This will be limit delta x tends to 0, f of x is 0. Oh, sorry, this is delta x, na? I wrote it as such. Why you didn't correct me? Delta x. Okay, so f of x is 0. So it's going to be delta x minus f of 0 divided by delta x. Correct? Now you tell me what is f of delta x? A power delta x. Limit of delta x tends to 0. This will be a power delta x. Tell me what is f of 0? When this x becomes 0, this is what? A power 0 is what? 1. Correct. So minus 1 divided by delta x. Isn't the same thing here? Okay. So what this is, so what we have, the way we have written is, so what this is, this will be nothing but f prime of 0. Correct? And this is f prime of x. Therefore, f prime of x, f prime is df by dx. Okay? So this is another notation you can write, f prime of x. And this is df by dx at, what the meaning is? df by dx at x is equal to 0. That's what we write it as x prime. That's what we have done it, right? So we should write. So this will be, we written it. You got it? Huh? So I'm removing this thing so you know it now. So f prime of x will be equal to f of x into f prime of 0. So what is the question we are asking? What will be the function for which df by dx equal to f? We almost got, correct? So only thing is, if this one, this guy, if somehow, if this becomes 1, so then we got the condition. That's what you have to do, correct? This is what? F prime of x equal to f. That's what is that. So now what is f? So if you see, so what is f prime of 0? This is f prime of 0. Okay, so for limit delta x tends to 0, a power delta x minus 1 divided by delta x should be equal to 1.
Okay.
Correct? And if you see, so here, so there should be one particular value of a. When you do it, so there should be, for any a, it won't become 1. So the value of a, because delta x all are going to 0, only one number is there, right? There should be only one particular value of a for which this becomes 1. And that a, this gives you a equal to, that's what your, what they call it as an exponent, the symbol is Euler's number e, that will be 0.718. It's a rational number, it goes on. Okay, so we can write, so rational number. So this number is called as your Euler number. Okay, so what it says, whenever a is equal to e, okay, when a is equal to e, your f prime of x will be equal to f of x. Correct? So that gives you the next formula. So what we are going to do, so now, so all we have to do is, so what we are, I am going to remove these things. Let me remove this side. This is not required. So what we are saying is, so when a equal to e, all I have to do is, in the place of a, if I put this value e, then f of x will be equal to f prime of x. Correct? So then what happens? So if your f of x is equal to, in the place of a, put e power x, then what will be df by dx?
F of x.
What is f of x?
F of e of x.
Correct. Okay. So this is the second formula what we have. So we wrote it for a constant, this is equal to 0. And now when you write the thing in Euler's number, what's Euler's number? When f of x is equal to e power x, df by dx is also equal to e power x. Okay, there's one more formula which I am not going to prove it, we can do it later on. Now let us have another formula. Okay, so that's what, suppose if your f of x is equal to x to the power of n is some number. Okay, this I think this we saw it in some mathematics class, in earlier class also I wrote it like this. I wrote this. Okay, so it is simple. So in this case, this formula is very common formula you will be using. It's very simple. So in case df by dx, I'm not going to prove this. Okay, so you can in a 12th standard you will prove this. This will be what? N into x to the power of n minus 1. Remember this formula also. Okay, so this formula. So you know for an e power x, df by dx is e power x. You can show this is 0. For this you remember it. Okay, and now if you know these two, and can you tell me what will be df by dx? Sorry, what will happen when f is equal to e power ax, f of x equal to. So let us try to do that. So if you have f is equal to e power ax, what is our df by dx? Okay. So to get that, we should use one property of the derivative which we missed last time. Okay, so I didn't tell you the last time that property is an important property. So for example, if you have any function f which is a function of g and g is a function of x. So it's what? It's a function in function, I'm calling like that. So g depends upon x, or f depends upon g and g depends upon x. If you have such a function, so then what will be the derivative of that function? Df by dx. Okay, so this is what happens. So f depends upon g. We want to say, so what I'm saying is f is depending upon g and g is depending upon x. Now the question I'm asking is, so what will be the derivative of f with respect to g? So then what happens? So then what will happen is that will be the derivative of f with respect to g, that is df by dg into derivative of g with respect to x. This is a formula. Try to remember this formula. So if you have f is a function of g and g is a function of x. So in that case, what will be the derivative of f with respect to the innermost variable x? You got it? What will be the derivative of f with respect to the innermost variable x? That's what I am doing here. Am I right? So that will be what? The derivative of f with respect to g, that is here, and g with respect to x, that's here. Okay, and this is an important formula, you should remember it. Okay, உனக்கு கொஞ்சம் தூக்கம் வருது மாதிரி தெரியுது. நான் தூங்கிட்டு இருக்க மாதிரி தெரியுது, கவனம் இல்லாமல் இருக்குது கொஞ்சம். இல்லை கொஞ்சம் பார்த்துட்டு இல்லாட முடியாது கிளாஸ். பகலை தூங்க வேண்டியது தானே? அது சரி. So let us use போட்டிருக்கோம்ல கொஞ்சம். So let us use this property to find out the derivative of e power ax. Okay, so what this will be? So how am I going to do it? So our question is, what is df by dx? Okay, so if you want to see, I can write this function. Suppose we already know this function. Let me write g of x. Let me write g of x equal to e power x. Okay. And I am going to write f of g is g power a. Okay? You got it? So I am giving two functions. So now, what happens? So what is g? G is e power x. So if I write in the place of g, if I substitute this e power x, I am going to get e power x whole to the power of a. Now you know what is that? X to the power of m into n will be equal to x to the power of mn. Okay, so this is what? E power a x. So that's nothing but, so I have represented f in terms of x. Correct? Now there is no g. I almost removed all the g. I written only in terms of x.
So that should be f of g, right?
Which one? Here? This is f of g.
But then how can this be f of x?
This is x, no? There is no g at all here. This is f of g. See, when I write like this, this is f of g because there is no x at all. f of g equal to g power a. Something like that, f of x equal to x power n. I'm writing it f of g equal to g power a. Only I replaced x with g. Doesn't matter. You got it? So only thing is, what I am saying, the earlier equation I have written, but my g is equal to e power x. You understood? This is what I am saying, the function. Means when you have the depend upon many more functions like this. So that's why to solve for these cases, this property can be very handy. So let us try to use that property. So what happens? So then we will use this property. So df by dx. df by dx. That's what this, right? And that's what the derivative we want to find. So, and we know f, what you have written. So f will be g is a function of x. Correct? If I put here f is a g of f of g of x. The same property, right? So I can use same property. So whatever this will be df by dg into dg by dx, right? So what is df f in terms of g? Because I'm taking a derivative with respect to g. So I shouldn't write this. I should write in terms of g. Correct? So this will be what? d by dg of g power a into dg by dx, that is d by dx of, what is g? g of x is e power x. You know, e power x is equal to what?
df by dx.
When f of x is e power x, df by e power x is equal to what? And tell me what will be this? What will be this quantity? We are done, na? F equal to e power x.
Okay, so
df e power x by dx will be what?
but how will that be multiplied by d by d of x?
This one? G, na? What's your g? G is our e power
d
x.
of x.
Huh?
Okay, no, but e of x will be df by dx, but then that will be d by dx into.
Wait, let me explain you. You understood this formula? This formula is there. So now tell me, where is the function which relates f and g?
f and g,
This one? Correct? So this is going to be df by g, so I can replace f with g. So this will be what? So this is going to be d by dg. In the place of f, I am going to write g power a.
Okay.
Am I right?
Okay.
Or if you are getting confused, let us write it separately. Okay, so let us write it. So you know f is equal to g power a. Okay. So therefore df by dg will be equal to the same thing, na? F equal to g power a. df by dg equal to what? In the place of x you have g. That's all. Nothing.
Okay. So
Correct? Tell me.
dg by dg by.
I am asking if f of x equal to x power n.
Okay.
I wrote this formula, right? If I say f of f is equal to g power a, what is df by dg?
No, that should not change, right? Because even if it's df by dg, then
F equal to x power a.
Okay.
What will be df by dx? What will be df by dx?
ax into n minus a minus 1.
What I am asking here? Correct. I have done nothing. I just replaced x with g. I am asking you the simple formula. So what this should be?
This will be ax into
No, ax is not there, na? A,
g
right?
is to power of a minus 1.
A minus 1. That's what you have to write. Correct? In the place of x, I just replace g. That's it. How does it matter? You write g or x, whatever the formula is same, na? Okay, so this is what. So df by dg equal to ag a power 1. So now let me write down the next one. dg by dx. Okay. So what happened? Your g is equal to what?
E of x.
E power x. So dg by dx will be? See whether you have done that formula here, anywhere else?
There.
Alright. In the place of f, I have g, that's all.
Okay.
So what this should be?
So no, that should be
if f equal to e power x, df by dx also equal to e power x. If g equal to e power x, dg by dx should be equal to?
So also be equal to e power.
That's what I'm asking. So this will be what? E power x. Am I right? Be attentive. Okay, so we got df by dg equal to a g power a minus 1, dg by dx equal to e power x. So let us write this one. So this will be what? So this term I am going to write it as a g a minus 1 into e power x. So now let us put back, but we don't want g because we want in terms of x. So we want to replace g. We know what g is. Am I right?
G is e of x.
Correct. Simple. You put, you will get the formula. So what we are going to do? So this will be a into g will be e power x. E power x into a minus 1 into e power x. Tell me what this is.
Okay. Should add first e of x a minus x plus x.
Okay, if you want to do that, okay, let us do a into e power ax minus a. Is that you want to say? Sorry, minus x. Minus x, correct. Okay. Minus x plus x. Correct. This x is also there. Right? So what this is?
A of ae is the power of ax.
That's what the formula is. Okay. So if f equal to e power ax, df by dx is nothing but a into e power ax. Okay, so that's what I'm saying. What are many times, if you remember the properties of these derivatives, you can, suppose even though if you forget the formula, you can derive all the formulas. Okay, so only certain formulas are important. For example, this formula and this anyway. So only ex is the only function where derivative also will be same. If you take a derivative of d e power x, it will be again e power x. That's what the whole problem we are trying to solve, right? Fine. And okay, so let us go for now. Let us go for So now, which I think I will not go into the solution of it. Rather, I will not prove it. We will just write down. So it's same thing. So if you remember, okay. So I told you. So something like log of x. Okay. What they have is natural log. Natural log is, so this is the important thing is, your e is an interesting number. Okay, because e is a number, I said, because when it is e, why e is a number is, df by e for f of x also will be e of x, and df by dx also be e power x. Okay, so what they call is the inverse of it. So what I am saying is, suppose for example, we have e power x. You wrote e power x, right? Let me call it as say some y. Can you write it in log?
Log of e of y.
Log of base e
Base e
of y should be equal to x. Okay, when the log of base e, this usual notation is they simply write ln. When you write ln, it means log of base e. What they call is a natural logarithm that you will learn later on. Ln of y equal to x. Okay, so this is one property. Okay, so now, so the ln of x, so ln of y, you can have ln of x, ln of a, ln of b, ln of z. So this from here you can write down, from the exponential you can get a natural logarithm. This is called natural logarithm. Okay, so you should remember this also. I am not going into it. Okay, so what they say is, suppose, okay, so I am not going to write, so I can similarly I can have x is equal to e power a or something like that. So what will be ln of, or log of base e of x should be equal to a, correct? So, and this will be what? Ln of x is equal to a. Right? So this can be also a function. So now the question is, I am asking is, suppose your function, okay, you understood, learn. Suppose your f of x, equal to ln of x. We never know what ln of x is. So the ln of x can be there. Okay. So log of x. There's a log base e of x. So what it means when I write ln of x, you should remember that means log of base e of x. So what it says is, so what should be e power a certain quantity, let me put a question, that should give you x. So this is the quantity will be equal to. Okay, so its meaning is that. So when you do the logarithm, you will be able to understand it better. For time being, you consider, yes, assume this is logarithm. So logarithm is a kind of an inverse of e power x. That's why we are doing it, right? So tell me. So in this case, just remember the formula. So in this case, df by dx will be equal to 1 by x. So either you can write df by dx or you can write like this also. You are getting confused. I can write this as d by dx of ln x also. You want it? Because basically replacing f with ln of x. So that's why you are getting confused. Am I right? You can write with this way also. It's not always you have to write step by step. Okay. So this is another function what we have. So as you keep doing more and more problems, this will become easier. And next two things are for the trigonometric functions. So trigonometric functions are simpler. Okay, I will tell you. So you have sine of x and d by, the same thing is if f of x is equal to sine x. Okay, so we have other, they have given all the trigonometric functions. Okay, fine. So in this case, you understand what I have done? F equal to sine of x. Instead of writing like I am writing directly. Will be cos x. Okay, I am not going to prove this. Mug up. Okay, you will learn it at 12th standard. D by dx of cos x will be equal to minus sine x. Remember this sign always. Often the mistake happens if you put sign here and sign here, the whole problem is going to be wrong. Okay, so it is that's why you should keep on practicing. Okay, so normally you remember this formula. So these two formulas. Okay, and then rest of the formulas are simpler, So for example, if you are given you sin x and cos x, if you know, then you can find out this also. What will be d by dx of tan x?
That will be d by dx of sin x divided by d by dx by cos x.
No. d by dx of sin x by cos x. Okay. This will be what? Don't do that. So it will be d by dx of sin x by cos x. Okay. So it is something like, if you remember yesterday in the previous class, we show one more property. You remember the property? What is the property is? If I give you two functions, f1 and f2, if you take a derivative, f1 of x, we have f1 of x and f2 of x are two functions of x. What will be d by dx of f1 by f2? You remember that? So we wrote it as 1 by f2 into df1 by dx minus, f1 by f2 square into df2 by dx. You remember this? Correct, yes. This function. So, isn't it the same? In the place of f1, you are having sin x. In the place of f2, we are having cos x. So, we can solve it. If you remember this formula. So, that's what I'm saying. Remember these properties of derivatives thoroughly. Okay, so most of the formulas you can derive from there itself. So, let us try to do it. So, what happened? Tell me. Tell me this one. So, this will be what? So, d by dx of tan x will be 1 by f2, correct? That is 1 by cos x and then df1. So, that is d No, f1. Yeah, d by dx of
Sin
sin
x.
x. Correct?
Ah.
And then minus f1 by f2 square. f1 is what? Sin
Sin
x
x by cos x square.
cos x square.
Cos square x square. Cos square x.
Okay, cos square x. Correct. Very good. So you remember it. Cos square x. Let me write it big. It's too small. Sin x by cos square x. And then what will be? D f2 by dx. That is, f2 is cos x, na? D by dx of
Cos x.
cos x. You got the formula?
Ah.
So this is simpler. So if you do, it will find the answer. So what is d by dx of sin x? Tell me.
Cos x.
Cos x. So this is going to become 1, right? Cos x becomes, so this will become 1. Because this become cos x cancels, become 1. Minus sin x by cos square x into d by d of cos x is?
Minus sin x.
Correct. So it is minus sin x. So that will be what? 1 plus
Tan square x.
1 plus tan square x. Can you tell me what is 1 plus tan square x?
Sec square x.
Correct? Okay? And that's what your formula is. So therefore, so we have got it. So what d by d of tan x is nothing but sec square x. Okay. Same way, you can do d by d of cot x also. Now you can do all functions. If you know this formula, you can do all functions, right? So what will be d of cot x? Tell me. D by dx of cos x by sin x. Now use the formula. Tell me what it will be. So your f1 is now cos x and f2 is sin x, right? That's all we have. So it should not be a tough. So tell me, use this formula. Tell me what is
1 by sin x
1 by sin x
into d by dx of cos x
cos x, good,
minus cos x by sin square x
minus, okay, write it up, cos x by sin square x into d by dx of sin x, right? So what this will be? Tell me. So
minus 1.
this is minus 1. Yeah, cos x equal to minus sin x. So this is going to become minus 1.
Minus
Sin x is cos x. So of course this will be minus cos square x
square x by sin square.
by sin square x. That's what cot square x. Correct? So this will be minus
Cos square x.
cot square x, or I can take minus commonly outside, 1 plus cot square x. What is that?
Cos x square.
Cosec square x. That's equal to minus cosec square x. Okay. So therefore, d by dx of cot x is equal to minus cosec square x. Okay, so this way you can show all this, all the trigonometric formulas can be, and we can do this one also. What they given? Sec x. Okay, simple. D by dx of sec x. That will be what? D by dx of 1 by
Cos x.
cos x. So 1 is a constant. For a constant, the derivative will be 0. So you should remember, whenever it is 1, if you take a derivative of 1, it will be 0. Because any constant, take a derivative, that is 0. Okay, so in our case, what happened? f1 is a constant, f2 is a cos x. So what happens to the first case is,
First case will be 0.
correct, because 1 by cos x into d by dx of 1, that is 0. So of course this will go off. Am I right? So only the second term. So df1 by dx will not be there. So this will be there. Minus 1 by
cos square x
cos square x into
to d by dx of
d by dx of cos x. Am I right? So what is d by dx of cos x?
minus sin x.
Is it minus sin x? Yeah. So then minus minus becomes plus, right?
Sin x by cos square x.
So sin x by cos square x. So we write it as what?
Tan x by cos x.
Tan x, that is secant x.
Tan x sec x.
Correct? So d by secant x will be tan x into secant x. That's what the formula is. You understood? So it is not necessary you have to remember all the formulas. All you have to remember is this formula, one in derivative. Usually only few formulas you should remember. Other formulas you can just derive. You should remember these properties. Remember all the properties of derivative thoroughly. So then most of the formulas you can derive. So this will be what? Tan x secant x. So there's only one more function left over. Can you tell me what is that? Cosec x. In the same thing. It's nothing cosec of x. Correct? That will be d by dx of sin x 1 by sin x. Tell me. First goes to 0. Second case is 1 by minus 1 by sin square x. D by dx of sin x.
Minus 1
Sin x is equal to? Correct. So this will be minus cos x divided by sin square x. That's equal to what? Tell me.
Minus cot x cosec x.
Cosec x. And that's what your formula is. So you got understood? Minus cot x cosec x. Okay. This way you can, and that's all. The first problem is find the derivative of f of x equal to x power 8. Simple. So what do you want to do? Df by dx will be what? Tell me. Which formula you will use?
E of x? No, okay.
Where is there? E. Here. Okay, it's x, na? E is not there at all. E is just a number. Remember, E, I wrote you the number, right? So that's what E is. So, and yeah, tell me what this will be?
8x is to the power of 7.
That's it. Simple. Okay, n minus 1. Okay, this is interesting. Next one is this. So, suppose given the function is f of x is equal to x cube plus sin x. Find df by dx. You remember this is sum. If you remember, one more property we did in the previous class. Suppose if you have the function f of 1 and f of 2, d by dx of f of 1 plus f of 2 will be equal to df1 by df1 by dx plus df2 by dx. Correct? So isn't that the same? Correct? So what happened? This will be what? D by dx of this quantity plus d by dx of this quantity. So that will be what? So we are having d by dx of x cube plus d by dx of sin x. You got it, na? Because this is f1 and this is f2. That's what you have done. Correct? So what this will be? Tell me. 3x square. What is d by dx of sin x?
Plus cos x.
That's it. You got it? Okay, there's one more problem that's also interesting. F of x equal to x cube sin x. Okay, so there is some multiplication of two functions. Am I right? So you remember we wrote a division, f1 by f2. Same way we did one multiplication also. So if we have f1, f2, what is d of f1, f? Let me write it cleanly here. So what we have, so d by dx of f1 into f2. will be what? f1 into df2 by dx plus f2 into df1 by dx. Correct? So this is a property also we did the previous class. Okay, so remember all the properties. Otherwise, we'll make all the mistakes. So simple. So this is your f1 and this is your f2. Do it. So what happens? So df by dx equal to f1. f1 is x cube into d by dx of sin x. Correct? Plus f2 sin x d by dx of x cube. Tell me what this is.
Cos x
Sin x equal to cos x. X cube cos x plus this will be what?
3x square.
Correct. Very good. Because it's 3x square. 3x square sin x. That's it. Okay. So to solve, so it will become very simpler only if you remember all the formulas and properties. Okay, so if you keep on doing many problems, then you will eventually mug up all those things, and this problem will be easy. Okay, so tomorrow we will see this is what the whole thing about the integral differential calculus. Tomorrow we will do what I said in the earlier class. What is the antiderivative? So I said now if you have a function, derivative is nothing but a slope. The slope of the tangent at a certain point is a derivative. Correct? Suppose I give you slope. If I ask you the function, that's what I am going backwards. So that is what we call as the integral calculus. Okay, so we will see it in the next class. Okay.